So in an earlier lecture, when we talked about the equation of a parabola, we saw how to find the vertex of the parabola starting from its equation. And that's great. It works. We're going to kind of revisit that here, and we're going to do it in a slightly more algebraic way. And in the end, what we're going to have is a formula. X equals an expression in terms of A, B, and C that we can use to really quickly locate the vertex without having to go through some of the song and dance that we did with kind of that parabola analytic geometry based process, which is a good thing to have, because this is where is the high or low point, the maximum or minimum value. It's a very common question, so this is something we'd like to be able to do quickly. All right, so how can we do this? Well, it's going to be a little bit messy up front, but in the end, the formula is really going to be relatively simple. So what I'm going to do here is I'm going to start by rewriting this in that vertex form. Okay, so I'm going to start by completing the square. So I have to factor an A out of these first two terms. And so the middle part here will become x squared plus b over a x plus c. And now I'm going to complete the square. You remember how we do that? I take the middle term here, or I take the coefficient of the x, the b over a, I divide it by 2 and square it. If I do that, this is b over 2a squared, which is b squared over 4a. Okay, so I'm going to add b squared over 4a inside here. Okay, but of course I can't just do that, right? I can't just start over 4a squared, not 4a, 4a squared. And of course I can't just randomly add stuff here. If I do that, I have to balance this out. And the way I'm going to do that is by subtracting it. Because I can add 3 and subtract 3 to an equation, because that's the same as adding 0, right? It doesn't change it. So what do I have to subtract here? Well, don't forget I've got this a floating around out front. So if I multiply that a times the b squared over 4a squared, that's b squared over 4a. So that's really what I added, so that's what I'm going to subtract. I'll subtract b squared over 4a. Now I can factor this thing. This is a times x plus b over 2a squared plus this weird thing at the end, c minus b squared over 4a. Okay, good. Now, here's where I get my formula from, right? Remember what I am trying to do, right? I'm trying to find the vertex of this thing. Let's assume, for the sake of argument, that a is greater than 0. All right, you remember from our previous conversation, that means my parabola opens up, and I'm looking for the x coordinate where the function is at a minimum, right? Because the vertex down here is a minimum, it's the lowest point. All right, so how can I do that? Well, remember first, this is the only part here that has a variable in it. Okay? X plus b over 2a squared is at a minimum when it equals 0, right? Because it's always positive. I don't care what number you put in here for x, when you square it, it becomes positive. So something squared is at a minimum when it equals 0. So when does x plus b over 2a squared equal 0? I'll take the square root of both sides. X plus b over 2a equals 0, and you get x equals negative b over 2a. And that's it. That's my formula. All right, that's my formula for the location of the vertex of a parabola. And now, what about when a is less than 0? And you can kind of walk yourself through this if you like. If a is less than 0, it's the same thing, right? You're still trying to find the value that minimizes the value of this part here, and you end up getting the exact same formula in both cases. So this is it. This is our formula here. If you want to know, if you're given a quadratic equation and you want to know where is the location of the vertex, well, it's equal to this. It's equal to negative b divided by 2a. Okay. So that's the x coordinate. How about the y coordinate? All right. Well, what I'm asking is, what is the y coordinate when x equals negative b over 2a? Well, look, refer back to this line here. Right? If I put negative b over 2a into that equation, what do I get? Well, it's y equals a negative b over 2a plus b over 2a. You see what's about to happen there? Squared plus c minus b squared over 4a. This whole part here becomes 0. And all that's left is y equals c minus b squared over 4a. Now that's not nearly as elegant a formula as the one for x. And in fact, I don't know anybody who ever actually remembers that thing. If you want to know the y coordinate, what you do is you find the x coordinate and you find the numeric value, or you find that x equals a number, then you just put that number back into the original equation, and you get the y value. And so it's, I don't know if it's necessarily faster, but it's definitely more elegant than trying to remember that formula there. So let's look at applying this formula is really pretty straightforward. But just so you can see, let's take a look at a quick example. So let's say I want to find the vertex of the parabola that's given by that equation. All right, well, I'm going to find the x coordinate using my formula. X equals negative b over 2a. B is 9, so this is negative 9 over 2 times 3. And that gives me negative 3 halves. All right, so then how do we go from there to the y coordinate? We'll take negative 3 halves and substitute into the equation here. Y equals 3, negative 3 halves squared, plus 9 times negative 3 halves, minus 5. Let's see, this is 9/4, that's 27/4, minus 27 halves, minus 5. We'll do a common denominator here, 27/4 minus 54/4 minus 20/4. What do we get? That's negative 27 minus 20 is negative 47, so it's negative 47/4, and that's it. There's my y coordinate. So the vertex of this parabola is at negative 3 halves, comma, negative 47/4. All right, so where are we going next? Well, again, kind of referring back when we talked about the equation of a parabola, we saw how to find the equation of a parabola, how to find a quadratic equation, given information about it. And the information we were given was very kind of parabola-centric, if you will. We were given the vertex and the directrix, or we were given the vertex and the focus, and that's all fine, right? But what if all we know are points? Or what if all we know is the coordinates of the vertex and the coordinates of another point on the line? Or even more generally, what if we just know the location of arbitrary points on the line? In the next lecture, we're going to see how we can take that information and turn it into the quadratic equation whose graph passes through those points.